Alright, so what is exponential growth? What is a function that exhibits exponential growth? So you've probably heard that term, like this, something's growing exponentially. Um, when the rate of growth of a function is proportional to its value, the function exhibits exponential growth, meaning the higher the value of the function, the higher the growth rate. So if you look at this visually, um, the higher this value is, y, the faster it's growing. So here y is pretty low. Let me just draw, so here's y, or alternatively called the f of x, the value of the function. Um, so here it's pretty low, right? And it's growing at a pretty gradual pace. Here, the value of the function is a little bit higher, and it's just a little steeper. It's growing at a little faster pace. Well, here the the value of the function is even higher, and it's even steeper, so it's growing at an even faster rate, etc. So the higher the value of the function, the more quickly it keeps getting higher. The more quickly it grows. All right. So some examples of things that follow this sort of pattern would be human population, meaning the more people there are, uh, the more the population grows because those people are having people as babies. And then when their babies have babies, so the more babies are being created, right? Another example is a nuclear chain reaction. The more atoms that are being smashed apart, the more uh, the more quickly atoms are being smashed apart because those particles are bouncing around and hitting each other more and more. So it's chain reaction. Another example is compound interest. Right? So the equation looks something like this. Um, x of t, so the value of the function at time t, is equal to, so this would be, let's call that t, call this f of t. Um, so the value of the function at time t is equal to the value at the beginning, so value when time equals 0, or x naught. So its starting value times 1 plus the growth rate. So 1 plus 0.04 would be a 4% growth rate. Um, in other words, uh, 1 plus zero point zero 0.04 would be 1.04, which would be 104%. So this is increasing by 104% um, each each time it grows, and then it raised to the power of t, so the time elapsed. So, um, say for example, this thing grows by 4% every year. So t would represent years. So x of, let's say, 3 years. So x of after 3 years would be equal to the initial value of x times 1 plus zero point zero 0.04 raised to the power of 3. So it's grown for 3 years at 4% per year. So that's the equation. It's the basic structure. You might see it labeled in different ways. There's different ways of symbolizing each piece, but the basic idea is the value of the function at a certain time is equal to the beginning value times 1 plus the rate of growth raised to the power of um, um, the time. So if you're measuring in years, that would be the number of years elapsed since the beginning. If it's in seconds, that would be the number of seconds that have passed since the beginning, etc.